Good morning, students. In this lecture, I am going to discuss a new topic in second chapter, which is electric potential due to a system of charges. Okay, you already know what is meant by system of charges. System of charges means huge collection of charges which are situating at different places. Now, due to all these charges, we are going to find electric potential at a point. So let us consider a case. I am having some number of charges Q1, Q2, Q3 and Q4. I can have n number of charges. For example, I am taking 4 charges. Now I am going to find the potential at a point P. This is my point P. I want to find the potential at P. In order to find the potential at P, let us first mark the distances from the charges. From Q1, it is at a distance of R1. From Q2, it is at a distance of R2. From Q3, it is at a distance of R3. And from Q4, it is at a distance of R4. Now, according to this system of charges, we can apply principle of superposition for electric potential also. So according to principle of superposition, we can find out the potential at a P. Potential at P, V is equal to V1 plus V2 plus V3 plus V4. Since only 4 charges are there, we have 4 terms, where V1 is the potential at P due to Q1. V2 is the potential at P due to Q2. Similarly, V3 is the potential at P due to Q3, and V4 is the potential at P due to Q4. And you know how to find the potential at P due to Q1, due to Q2, due to Q3, etc. For that, you are already having equation. So to find V1, you are having the equation 1 by 4 pi epsilon 0. You are having the equation 1 by 4 pi epsilon 0 charge by R. Here charge is Q1 by R. Now V2 1 by 4 pi epsilon 0 Q2 by R. V3 1 by 4 pi epsilon 0, sorry, this is R1, this is R2, this is R3, and V4 is equal to 1 by 4 pi epsilon 0 Q4 by R4. So the potential at P due to all the 4 charges is nothing but the sum of individual potentials, that is V1 plus V2 plus V3 plus V4, which is equal to 1 by 4 pi epsilon 0 Q1 by R1. We can take 1 by 4 pi epsilon 0 common because it is there in all the 4 terms. Q2 by R2 plus Q3 by R3 plus Q4 by R4. And here you can see that potential is a scalar quantity. It is not a vector, so it will not have any unit vector. This is the expression for potential at P. 1 by 4 pi epsilon 0 Q1 by R1 plus Q2 by R2 plus Q3 by R3 plus Q4 by R4. there won't be any unit vector because potential is a scalar quantity. Okay, so this is how you can find potential at a point due to a system of charges. Now if there are n number of charges, then potential at a p so in the same case, if you imagine there is a q5 here which is at a distance r5, there is a q6 which is at a distance r6, like that so many charges are there, then potential at p is equal to 1 by 4 pi epsilon 0, you can take it common, q1 by r1 plus q2 by r2 plus etc plus qn by rn. This is how you can find the net potential at a point due to a system of charges. This is nothing but principle of superposition for electric potential.